Welcome to Luca and Miguel. Enjoy the video.
You start by verifying the hardware and drivers. Run NVIDIA SMI to confirm the GPU and driver. Once done, pick the CUDA toolkit version that matches the Tensorflow release you will use. Mismatches break support. Then install cuDNN for that CUDA build and export path and LD library path so the runtime finds CUDA libraries. Make sure Package Manager installs use system packages or Conda to avoid conflicting files. This gets the foundational pieces in place before Python and TensorFlow installation. You now create an isolated Python environment with the exact Python version TensorFlow expects, using Conda or virtualenv to prevent conflicts. Next, install the GPU-enabled TensorFlow package from pip or Conda, ensuring the wheel was built for GPU support. Once installed, import TensorFlow and call tf. Config, list physical devices, GPU to see the device. Then run a quick tensor matmul on the GPU to verify execution. If it falls back to CPU, double-check library paths. You finish by tuning runtime options. Enable memory growth or set a per-process GPU memory fraction so other processes remain usable. Then run your real workload and monitor with NVIDIA SMI while viewing TensorFlow logs. If something fails, export CUDA visible devices to limit GPUs and enable debug verbosity to capture errors. Key troubleshooting tip: when things go wrong, the single most effective fix is matching the exact TensorFlow, CUDA, and cuDNN versions and reinstalling the NVIDIA driver. Mismatched versions are the usual culprit.
Thanks for watching and please subscribe. It's the best investment you'll ever make.